Well, it's morning for me. I'm sure it is evening for many of you, which is when I stream now, which is pretty early in my day. Uh, this shirt has green on it. I have just realized. Well, we'll just handle that. It's the Seattle city skyline, and it's see-through because I'm using green screen. Hi, welcome to Live Coding with me, Rachel. I'm trying something a little bit different. I have about a 2 minute delay now from where I am and where y'all are in the chat. Ooh, goodbye. Hey, Epic Game Store, if you would not show notifications, that would just make me happy. We are going to be continuing working on a project that we've been working on for quite a while. And basically, the idea is we are rebuilding the New York Times dialect quiz as a virtual assistant, chatbot, conversational AI, whatever you want to call it. So instead of the original application, ooh, sorry, my audio is a little peaky. Let me adjust that down a little bit. So instead of the original application where there were multiple choice questions and you picked the answer that seemed most relevant to you. So here I'm a yaller. We're going to have people answer the same set of questions or similar set of questions, but with a conversational interface. So you'll get asked the question, and then you enter a free text input. And then after you've been asked all the questions, our little classifier is going to say the 3 states that it thinks that are the most likely that you are from, or where people speak the most like you in the United States. And we'll return those answers, and that's it. That's the assistant. So it's like a fun little quiz that you would do through the way that we'll deploy it. So we'll probably deploy it through Rasa X to begin with, and y'all can once we do that, which will probably be. I'm gonna be super optimistic and say, like, next week, y'all will be able to actually use the assistant we've been building for 6 months. Been a while. All right, and the live stream has caught up. So again, there's a 2 minute delay. If it takes 2 minutes for me to respond to you, I'm not ignoring you. It is just that I am doing other things, like being in the future. A little bit of tea. I've got a tea today instead of coffee, a really nice pour that I've been saving for a special occasion. And the special occasion is I'm tired. So, what have we done so far? We actually have already built the assistant, and we already built a classifier, and we got it all working. And when I was doing my initial testing before launching it with Rasa X to share and do more robust testing, the answers that I was getting out were ludicrous. Were not just wrong, but were wrong in a way that suggested that the underlying model was making errors that were unreasonable. And the reason that I knew that is because I have, Henrique says, you're transparent. Yep. I made poor fashion choices today. I do need to do laundry. The reason that the underlying model was having such big problems is when I originally got the data, courtesy of BurtBox, thank you very much. The problem is that it came in a numerically encoded format, and I had to sort of guess which answers corresponded to which number, and I guessed wrong. So I got a different copy of the data, and that one was different because I had the data dictionary. Wow, little sip of tea. Hi, Robbie. No, we're not finished yet. We'll get there. This is, it's going to be something that I continue developing for a while. And I really only work on it on stream, so if I was working on this full time, it would have been maybe a 2-week project. Even with this pretty bad setup. Hey, Anarchy. So we got a new data set that we had a data dictionary for. We went through, we trained a k-nearest neighbors model, and what we did last time was we looked at the top 3 states is the level that we're working on, and based on our test data, we had the correct state in the top 3 states about half the time, which is, that's not bad for a fun little online quiz, and the top state the most likely state was the correct state about 30% of the time based on our testing data that we'd pulled out. So I'm pretty happy with this model. It seems to have results that are kind of in line with what I'd expect. And when it does make errors, they don't seem to be deeply unreasonable. So states that it picks tend to be, when it gets things wrong, the states that it do pick tend to be not super unlike the states that that are similar to the state that it did. Does that make sense? It's not going real off-piste. It's keeping it pretty much on the straight and narrow. Robbie says, first semester completed in Rasa. Yeah, it's been about 6 months since I joined, so yeah. All right. Today, we have a model that's been trained that I'm pretty happy with, probably room for improvement, but we are looking for a viable proof of concept that people can start using so we can improve our model over time. And I'm perfectly happy to come back and retrain this if we think that we can get some more improvements. A little sip of tea. And what we want to do today is we want to take the model that we've trained and all of the encoding, and we want to get it in such a state so that we can put in an array or a list of text input from a user, because that's what the user is going to provide us is text, and then we'll do data validation to match it to the right answer from our multiple choice question bank, because the original data is multiple choice and there is an other option as well. And we want to take that whole sort of like pipeline that goes from text answers of questions to an encoded, numerically encoded vector that matches the numerical encoding of our original data, and then takes our trained model and then applies it and then returns the top 3 states. So that's our point. That's what we're going to be doing. Hello. Amun says, I'm new with Rasa. It's been a week. Any tips for me? I think the best tip that we have is really to focus on conversational driven development. So there's a blog post that just development. So we have a lot of driven. I misspelled very badly. So we have a blog post that came out a while ago about what it is and how it works. And basically the idea is that you don't have to spend a lot of time upfront guessing what conversations are going to be like. You want to create a minimum viable model, sort of a prototype, and then immediately get it in front of people. So that's my number one piece of advice is as soon as possible, get something that kind of works and get it in front of your test users and refine it there. Yeah. All right. So that's what we're going to be doing today. We're going to be putting together that pipeline where we take in text input, encode it, hopefully correctly, because this is what's bit me in the past, and then have a saved version of our model and apply it. So one thing that I've been talking about, or that I talked about last time if y'all were here, was saving out the model. So the most common way is to serialize it using Pickle or JobLib or this or something. The big problem with serializing a model is that it relies on the Python environment that it's being deserialized into having the same, or at least non-breaking differences between the versions of all of the packages that it uses. So even though it's faster when you get started, it is much more likely to break then a version of saving your model that saves the parameters and then reconstructs the model. The big problem with trying to save out the parameters, or sort of like the things that you would need to reconstruct the model for a k-nearest neighbors model, is that it's non-parametric. And I've been digging a little bit into the internals of k-nearest neighbors using scikit-learn, which is the implementation that we've used here, and it's not entirely clear to me how I could, in a space-conscious way, write out those parameters and then load them in. So, at least for this first pass, I am gonna serialize. Probably, what did I do last time? Let's see. Because again, I have done this all before with a different data set. And the reason I needed to go back and redo everything and couldn't just use my same modeling code, dump, was that from this or pickle? I'm pretty sure it was from pickle. Let's go up to my imports. Joblib, okay. Joblib is what we ended up doing there. So I'll probably use that again because it did work. And we'll just deal with version mismatches and weird bugs when they happen to us. But likely that is what's going to happen at some point, especially if if this is something that I'm serving for quite a while. So, hello, nice to see you, Enrique. We also learned US geography. Yeah, a little bit. There's a lot of states in the US. All right. So I think that's what we're gonna do. I think we're gonna use joblib. So the thing that I want to do now is I want to go through and pull out the functions we've written that we'll need. So basically I'm going to start a new notebook. And I'm going to use the new notebook to test the pipeline and to sort of create the same sort of thing that I'm going to need in my assistant. So the way that it's going to work in our assistant is in your Rasa server, you need your cluster. You need the Rasa server, and that's what's handling the conversation, what to say next, figuring out what your user is saying to you, and the conversation part of that. And then there's a separate server called the action server, and that's where you can run any arbitrary code. And in our case, the action server is going to run Python code. It's going to run the form. So instead of writing a bunch of stories where I'm like, I asked this question and they give this answer, I just have a list of questions I want to ask, and it'll go through and ask all of them in order. Big time saver, and then validate the data as that comes in. And it will also be where we run our machine learning code and apply our model as the user provides the information. So let's get started by creating a new notebook. Wow. New file. Oh, it is just Control N. So let's call you... How? Oh, do I need to create it in here? I think I need to create it in here. All right. So let's call this I, Pi, N, B. There we go. Did I misspell? I did not. Excellent. It knows that it's a Jupyter notebook. And what I'm going to do is I'm going to go through and do pseudocode in a bunch of cells and to do all the things that we need. So the first thing that we need is read in... So this is just going to be something that we're only doing in this example. In our final assistant, the sample data will be provided by the user once they finish the quiz part. So read in the sample data, so import everything. I should probably do the imports ahead. I don't think there's anything that I'm going to need only to read in the sample data, because I am going to need pandas for the encoding. So we'll leave the front matter up there. So we're going to read in the sample data, encode it, so change the text input into numbers using the same way that we did it the first time. Read in the model, apply the model to the sample data. And the sample data is just to check that we're actually doing it correctly. And then we're going to, I'm just going to say, and return results as one thing. Okay, so those are all the steps that we need. Let's start by importing the things that we're going to need. We're going to need to import pandas as PD. Pandas is a library that handles tabular data, like it kept auto-completing. I just wanted to import that. I'm gonna want to import numpy as MP. We're gonna want to. This is extremely frustrating. Don't do that. I do want to alias it as NP. I do know what I'm doing. Please don't mess with my code. I'm going to want to import joblib, which is what we're going to use to read in the model that we've serialized in the other notebook. We retrained the classifier. We're going to need scikit-learn because we need to have the predproba military method in order to predict the probability. So I'm going to make sure I get I don't need to import all of scikit-learn, and that is a chunky library, so I only want the ones that I need. Don't need that. Yes, I think this is what we used. All right. Is there anything else we're going to need? I don't think so just at the moment, so I think we are good to go there. My second question is, do I have sample data ready to go? So we have this empty data structure here, and this is what we're going to use for the encoding. Oh, there's a comma in this. Well, we'll just deal with that, I guess. So this is what we're going to use for making sure that the encoding is correct. So I think we should probably load that in. Encoding sample equals pd.read underscore CSV, and then the file is called Why did you delete the thing that I wrote? Yeah, I know there's a typo error. I didn't mean to run that. What was it called? Empty. You're not gonna tab complete for me, are you? sucture.csv. There we go. All right. So the encoding sample, which is not sample data, it is all zeros. So we don't want to try to. I guess we could try to classify that. It's just not going to be very helpful. And then we want the sample user data. Trying to think of a good way to do that. Enrique says, what are you using XGBoost for? So I used XGBoost for the model with the old data set where I had zip code and city and state and etc. And I was shooting it more as I used XGBoost for that, and we had much worse performance in terms of accuracy than we did on this data set with this model. We had top 3 accuracy of about 50%. With XGBoost, with the old data set, we had top 3 accuracy of about 5%. So this is much better overall in terms of performance. Enrique, is VS Code free? It is free. Robbie says, who dares to compete in typing with Rachel? I mean, I am dyslexic, so I think most of you could probably type better than me. Or at least with fewer errors. Oh, there was Jerica. So I actually did take typing in high school, and Jerica, who's one of my classmates, is to this day the fastest typist I have ever met. I wonder what she's doing these days. I think she still lives in Virginia. Okay. I think the quickest way to get sample data is actually just going to be to randomly sample. Beep-a-doop-boop. Beep-a-doop-boop. Can I just... Alright. Data head 1. And then I'm going to save out this file. One sec. I know we did this in the exact same notebooks. I'm just going to scroll down and steal my, reuse my old code efficiently. To CSV. Okay. To CSV sample case data dot CSV, and then there was another argument there at the end. What was that? Index equals false, which I think we do actually want. I don't think we want the index. And I have to type out all of the letters in false. In R, you can just use a capital T or F to mean true or false. All right, so sample data should be sample case data dot CSV, but I actually do need to read it in. And this does mean that we're going to need to so the sample case data that we have here has information that we're not going to have in our final data set. So specifically it has, if we check, whoop, no, that's not what I wanted. There we go. So specifically it has user ID, county, and state, which are all leakage, right? Those are the things that will tell us the answer. Well, user ID won't. So I think the way that I get just the first 3 rows is like so. Nope. 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 Shoot. Is it a function? All right, on columns 3 onwards, again, I'm pretty sure I have code I can reuse. Robbie says you get a lot of errors. Yeah, that is perfectly normal. Oh, I was right. There isn't a 3rd index. I don't know why I thought there was. Nothing wrong with getting errors as long as you can. There we go. All right. Figure out how to go back and fix them. If you weren't meant to get errors, we wouldn't have written error messages. All right. Okay. So now we should have something that's going to be a closer facsimile of what we are going to see in our finished assistant. So now I should be able to just look at sample data and it should be, yep, excellent. So we don't have the leakage information and it'll be more parallel to our final thing. All right, so now we should be able to do the encoding, and I believe I wrote myself a little sample code. Here we go. To do, include this with participant responses. In order to match this with our user responses, we'll need to use the .align function with a left join, which requires the dataset to join to. So we'll create a dataset of a single row and then delete it after the align plus join. All right. Okay, so this is where we read out the data that we were using as a sample. Excuse me, we were using as a sample. More T. So it was the align function. Dot align with left join. All right, let me see if I can find. It looks like I didn't leave myself a code sample, which, why not? I guess I'm gonna look it up. So pandas align. Let's see if I can find the documentation. Boopity boop. Here we go. Okay. So it is a method of data frame, and not a method of pandas that takes two data frames, which would also have been a way that you could have done it. Self other join outer. All right. Align two objects on their axes with a specified join method. Join method is specified for each axis label. All right. So let's give this the old college try. All right, so the encoding was, we're going to take encoding sample. I think I said left join, right? Dot align. And then to sample data. And then join should be left. Okay, so we're doing one hot encoding. I know I said numeric encoding. That's not what we're doing. Okay. Robbie says, you're consistent in error. I mean, it's fine to keep working and running into errors and solving the errors and running into errors and solving the errors. That's the job. I would say if you are writing code without any errors consistently, you are writing code that you should not be rewriting. You should automate that because it's clear that it's the same steps over and over again. Does that make sense? So if you, it's the same thing when people are like, oh, I've memorized a bunch of code. If you've memorized a bunch of code to the point where you can write the same code every time and get the same results, then you should not be writing that code by hand every time. That is a waste of your time. You should be working on the hard things. Does that make sense? That's just sort of my general philosophy, is that I want to be as efficient as possible. Okay. So, one row, 175 columns, lots of NaNs. I'm just going to really look at the shape of encoding sample, because my wondering here is, did I save the encoding? Okay, so it does have 175 columns. So the reason it has so many columns is that we're doing one hot encoding, because KNNs is a distance-based metric. So as long as all of your factors are, or all of your variables are one away maximum for each other, none of them are going to be weighted as more important. Whereas just having a multiple choice answer with more choices, whether or not each of the choices is more informative, if you're using label encoding, will result in disproportionately using whatever it is that has more choices, if that makes sense. Okay, so is this right? Because these are all zeros, is the thing that I'm... Where do all these zeros come from? Is it because I have an index? It might be because I have an index. Let's see. Yeah, okay, so there is an index, and I want to Can you remove the index of a panda's data frame? Is that what's making this weird? Because this should be a data frame, and it ain't. Don't need you. Right, this is what it should look like. It should have ones in some columns, zeros in other columns, and right now it ain't got nothing in nowhere. So, no, we did save it out with an index. Robbie says you do the same errors every day, like iLock. Yeah. That's fair. I prefer to work with tabular data in R, and a lot of my intuitions about how data frames should work come from R, because pandas is basically a re-implementation of some of the things of R. And sometimes those intuitions are helpful, and sometimes things have been implemented in a different enough way that they are not helpful. But honestly, I don't work with pandas and tabular data often enough, despite what this live stream may make you think, to make it worth it to spend a lot of time investing in it. Maybe I don't need to specify that it's a left join. Okay, so we do have the right I realize that I'm referencing the object before it's been created. Tuple should have no attribute shape. So, what has happened here is that we have two data frames, which, when left joined to each other, have been transformed to a tuple. Why? Why? All right, let's pull up the documentation again. All right. Data frame. It should output a data frame. Data frame or series. Yes. Where's the tuples coming from? All right. Default other allowed access for a level copy. Always returning copy goes false. No indexing is required. Fill value method limit fill access broad set returns aligned objects. We fill must be greater than 0 if not none. Maybe I need to specify access as 1 so that it aligns on the alright, don't indent. Maybe I need to specify that access equals 1 so that it aligns by columns. It's still a tuple. Why? Why are you a tuple? Fiberhybe says, it's the first time I'm watching this. Lost video back. Okay. Series aren't tuples, right? They're arrays. Are pandas series tuples? Okay, so they're lists. So tuples and series and arrays and lists are all lists. Huh. Huh. Huh, huh, huh. Do I know this is specified for each act and send off? Blah, blah, blah. Two objects on their axis. Okay. It's a method of data frame. I'm giving a data frame in. It only accepts data frame or series. So why is it giving us neither of those things out? Returns data frame type of other aligned objects. It don't though. Hi Aziz. Usual says, I think you can also use pd.merge for joins. Yeah, let's see if that works better maybe. Merge. Sample data. So I want the encoding sample to specify what, and then sample data, what columns exist. No common columns to perform merge on. Merge ops. Oh, that's right. That's why I didn't do it. It's because so the difference here between these two data frames is that we're using one hot encoded. The encoding sample has been one hot encoded, so it's much wider. The other one has not been one hot encoded, so it's much thinner. I think it's like 25 instead of 175 columns. And what I want to do is basically, oh, you know what it might be? I think I need to get dummies first. Okay, one sec. I think I figured it out. Okay, so I think we need to do get dummies for sample data. No, that's not what it is. Let's see. So pd. Oh, so it's a get dummies. Okay. I think this might be what the issue is. Let's see. Okay, excellent. So now we have one hot encoded this, and then we can merge, I think. I still don't understand why the, all right, now let's look at encoded data. And if this is a tuple again, I will be very sad. But you can see here that we have, for each of these questions, a bunch of NaNs, and then some of these are ones, which is great. That is what we are looking for. And dim? Nope. Length? Nope. Len? Is it a built-in? I can never remember the differences between Python and R here. Two. Is it a tuple of data frames? Yes. I see. That would have been helpful to have mentioned in the docs. Oh. All right. And it looks like the stream is disconnected, and hopefully it reconnects. Beans. I thought this really long delay would solve this, and it looks like it hasn't. Frustrating. Very frustrating. Okay, we are reconnecting though, so that's good. And we're back. Okay, sorry about that. There's going to be a little bit of a delay now again, and hopefully it improves. This big drink of tea makes me very tired. Oh, I do have more tea in the pot. Okay, so that makes a lot more sense. So the one thing that I do need to do from here is that I have these NaNs, and I need to replace the NaNs with 0. So then I think we should be good to go after that. Encoded sample data. And then we just need to replace the NaNs with 0. So Python, and thank you for the help, Michael, and Swayson. I did eventually figure it out, despite being very confused. What did I say I was doing? Oh, replace NaN with 0. Replace NaN values with... All right, excellent. And so we should be able to just say fill Na 0. That's a float. I don't want it to be a float. Well, maybe it'll be fine. Hopefully it'll be fine. We'll find out. Okay, so that is our encoding done. Fantastic. Okay, so then in the next step, we can get rid of all of these, is to read in the model. So the first thing I'm going to need to do is save the model. And the model that we ended up going with was this state 5NN. So what I'm going to do here is from joblib import dump, and then I'm just going to dump state 5NN, and I need to, I believe the second argument is the name of the file, and I'm going to call this state level KNN. Is there a file extension I should use? No, it looks like it's going to add joblib, so let's just give that a shot. Does it exist here? It do. Oh no, I do need to add something. So I'm gonna add joblib, I guess, just to be clear that it is a serialized file and not a non-serialized file. Okay, so now that we have that, we should be able to read it in. And what is the joblib dot load? That's what it's called. We should be able to do, let's call this state canon, and then the model, that's a misspelled state. I do see that now. Canon dot, there we go. All right, so now we should be able to take this model and apply it to our, it will bother me if I don't fix this though. So let's go back and fix that. I realize I've created a lot of junk files. Delete, yes, peace out, yes. All right, okay, that should be better for me feeling good about this. And that should read in, no problemo. And then the test model top 3. Okay, here we go. Oh, so I did need I'm pretty sure I've already imported NumPy. I don't think I need to import it again. So we've read in the model, and then we should be able to apply the model. So we're taking predictions from our model. We're predicting the probability for each of our 51 classes, 50 states plus DC. Using, instead of X-test, we want to use input data. Yes, I see how that could be. All right, and we have an error, which honestly I'm not super surprised by. Query data dimension must match training data dimension. Okay, how big was the training data? I think it was 172. Let's just try this really quick. So I'm gonna look at the xtest.shape, not state. Got states on the mind. 172, excellent. And then the size of our input data should also be 172. Oh, it's 175. I know why. It's because our sample data, has those extra 3 columns in the front. So if I look at this, yep, we have these leakage columns that we have removed. And I will iLock and then just the first 3. So now we should, nope, that was backwards. Just the first 3. Great. Okay, now we can rerun this all, and hopefully we will no longer see that error. And then I guess just print top 3. Oh, right. Okay, so we do need something else. We need the list of classes from the model. Ooh, actually, we might have that. So let me pop back over here. There we go. All right, so we have our function here that we wrote previously to get the top 3. Oh, actually, this does all of these things for us. So we can get rid of this. So we can replace this whole section here with this and then just apply it to make sure that it worked good. So get top 3, and the model is called state KNN, and the data is called input data. Fantastic. And then our results are Pennsylvania, Idaho, and Utah, which are not super close to each other. Idaho and Utah are fairly close together. But if we look at our original data, let's see, data dot head 1 dot state. Idaho is the correct answer. So our classifier has worked. We've actually gotten the correct answer for this sample data set in the top 3 results returned. So I think we are pretty much ready to put this in our action server. And what I am going to do is I'm going to stop. I'm going to restart. And that should clear everything. And then I'm going to run all of these in order just to make sure that I haven't left anything out or had any troubles or problems. And we get the same results out, and we do still get the same correct answer. All right. Yeah. Drop NA. Oh, yeah. So there is a little bit of a delay with the stream. But we did figure it out. I Googled it. Very normal. Ujwal says, is dump better than pickle.dump? So it's joblib versus pickle, and I don't remember why we went with joblib last time, but maybe. I think it'll depend on your specific thing, but I got it to work last time, so I know it'll work, and that's why I'm going with it now. Yeah. And we've disconnected again. Love that. I don't love that. I really hate the disconnecting that we have. All right, and we're reconnected. This is extremely frustrating. I was hoping that the extremely long delay would help with that, and it looked like it did for a couple streams, and it no longer is. I'm just gonna reply to Manish. All right, so we are good to go. What specific files do we need? We need this empty data structure. We need the, oh, I don't actually need to open them. We need the sample CSV, sample case data, this one. Actually, you know what I'm going to do? I'm going to create a new folder in here that just has the model bits. the bits that we need to run our model. Paste that in there. Nope, that's the wrong file. Did not mean to do that one. You can piece out. Yeah, please remove the cycle bin. Okay, so the sample case data we're gonna need, so I'm gonna paste that in there, just so I have everything that I need in the same place. We need the empty data structure .csv. Copy you, stick you up in here. And this will make it just a little bit easier for me to go back and forth and transfer things. We need the state level canon.joblib, which is our serialized model, with the full knowledge that this is very likely to break at an inconvenient time in the past due to updates of packages, and I'm just going to deal with it then. That's a problem for future Rachel. State level, and I think that's all we need because the serialized model also contains our thing. What's the other thing it contains? The classes, the list of classes and labels in order, which is the other thing that we need to make this work. And then I'm also going to stick a copy of the sample pipeline in there as well, just so we have that easy to refer to. All right, so that should be everything that I need. The sample case data is just for me to check right now and to have available to look at if I need it, and to verify sort of the data structure and shape. And otherwise, I think we are pretty much good to go. Things that are going to be a big old pain in the butt in the future is that the data here you can see has the question number as the column title, and I have been saving things using the slot name, which is more informative. So like this one I think is like caught or open O. I don't remember what I called it. This one is like second person plural. This one is yard sale. This one is lightning bug or firefly or something. I don't remember what I called them, but the slot names are a little bit more informative than the sort of question numbers, which is the other thing. All right. Yeah. Manish says you're going to share the code in GitHub afterwards. Yes. So I have permission to share the code that I write and use, which is the the assistant itself, so that's available in the YouTube link. I don't have permission to share the code, not the code. The code I can share. It's a Apache 2.0. I don't have permission to share the full data set from the original data set collectors who are letting me use it very generously. So that this modeling code I'm not going to share because it just won't work for you guys because you don't have the data. But the rest of the code I do have permission to share, and that will be on my GitHub. Swayson says the Scikit one hot encoder is a bit more robust than Get Dummies. Oh, noted. I'll check that out next time. All right. Are these Rasa messages from a bot? No, those are me typing on a second computer. All right. I feel like this is a fairly good stopping point for me today. So what we will start with next time is, now that we have everything we need to get this all up and running, I guess what we could do is put these into functions so it's a little bit more modular. We have about, 5 minutes left. Oh, and I have to stop early because of the delay. I don't know how long the delay is anymore. So I might just, call it here. And then what we'll do next Wednesday is we'll go through and take these little bits and actually put them into our assistant and replace the bits we had from earlier, which were for the old model that did not work, the bad model. If you recall. So yeah, I think what we're gonna do next week is take the packaged model and pop it into our assistant, and hopefully that'll only take an hour. The big thing is gonna be getting the data validation set up, because we have different class labels and different answers, slightly different answers for this particular one. And I did, somewhere in here there should be a data validation something. JSON. Job lab, CSV, CSV, there we go. Okay, so we do have answers for the, could you not make this, add some line breaks to make it easier to read? So we do have this where we have the name of the slot and then the possible answer.